So, next we will discuss on a lexical analyzer generator tool called Lex. So far whatever techniques we have seen, like say from the regular expression, so you can construct NFA, from NFA you can convert it into DFA and all that. So, you can always write some programming language, using some programming language. So, you can write programs for implementing those lexical analyzers, but many times it becomes cumbersome, particularly if the language for which you are designing the lexical analyzer is huge. So, there are large number of tokens or identifiers in that language, then it becomes very difficult to construct or write the corresponding program. So, actually this tool Lex, it came with the Unix operating system. So, Unix operating system designers, they found that this is a very useful tool if we can have a set of application softwares, or which in some sense became a part and parcel of the Unix operating system, that can be used for generating the compilers automatically. So, in that direction, the first tool that was developed is this lexical analyzer tool. So, here it says that for a particular input language, so you can write down a specification file for the tokens that you have in the language, and so corresponding regular definitions and all, and put them into a file called this lex.l. So, this lex.l is a file, is a text file where you write down the regular definition and corresponding actions, like when that particular regular definition is found in the input stream, what the program is supposed to do. So, it may for example, if it is an identifier, so it may like to install that identifier into the symbol table. If it is say some number, so it may try to get the corresponding integer value, like if it is an integer number, ultimately the input program is nothing but an ASCII sequence. So, from that it may want to convert it into a proper number. So, that way so those things are done by this lexical analysis tool. Apart from that, so we can write down some portions or some actions, so that these white spaces are skipped. So, like that, so all those regular definitions that can come in the source language program, so they are written their definitions are written in this file lex.l, and there is a tool called lexical analyzer. So, original Unix operating system, it came up with the tool called Lex, and later on, so there are many updated versions of it. One is known as Flex, another is for Java enabled things. So, there is Lex and all. So, these are there, but essentially all of them are same in the sense that they are generating a lexical analyzer. And if you pass this your lex.l file through this lexical compiler, then it generates a C program lex.yy.c. This lex.yy.c, it has got a built-in function in it. So, if you open this file, you will find that there is a function yylex. So, this yylex function, so you can call it repetitively, and it will return the next token that is available on the input stream. So, if you just write a main program where it repetitively calls this yylex function till end of file is reached. So, if you do something like this, then it will be returning you all the tokens that are appearing in the input program. So, that is one possibility, but the way this lexical analyzer is used by in a compiler design is that the parser, so it in turn calls this yylex function. So, whenever it needs a token, it calls this yylex function, and it works like that. So, this lex.yy.c, as I have said that this is a C program. So, this has to be passed through a C compiler for generating the object file. So, so this is written here as a.out, because in Unix operating system the default object file name of the object file is a.out. So, you can give some other name also, whatever it is. So, this is the executable file that is produced. So, this is actually the lexical analyzer, this a.out is the lexical analyzer. So, if you run this program a.out and you give it an input stream, then so this a.out program, so it accepts input from the keyboard and it produces output to the display. and there are some variables y in and y out. So, this y in, so this is the input stream. So, this is the input stream pointer from where it will read the input. So, if you do not mention anything, so by default this y in is set to the keyboard and y out is set to the display. So, that way it operates. So, if you want that the input should be read from some other file, some input for example, you might have written your input in some file, the input stream maybe in the file say file dot, say this is say name of the file is say file 1. So, what you can do, you can open this file and set y into this file. So, you can write like y in equal to f open say file 1 in read mode, etcetera. So, the standard C program for opening a file in the read mode. So, in that case, from that point onwards this y in, so it will be accepting input from this file 1. So, whenever this ylex function is called, it will scan through this file and whatever be the next token that is available, it will return it. So, this a dot out process, so this lexical analyzer tool, it will generate the sequence of tokens. Okay. So, that is how this lexical analysis tool generator, so that can be useful for compiler design, or you can, if you have some very simple text formatting sort of application, then it can also be done using this lex tool. So, you for certain input pattern, input stream, you want to generate something else, so that can be done. So, you can do it using some other tool that way. You can use some action. So, we will see how the actions may be written, so that we can do something for them. So, structure of a lex program is like this. So, it is divided into 3 sections as I said earlier. So, it is divided into 3 sections: declarations, translation rules and auxiliary functions, and they are separated by this double percentage characters. Okay. So, in the declaration part, so you can write down all your regular declarations, etcetera. So, that you can have, that you may use that you may be using while writing the regular expression in the translation rules. So, in the translation rules part, so it is so you have to write the regular pattern and the corresponding action. So, we are not writing it regular expression here, because this pattern is more powerful than regular expression. So, in regular expression we can write something, but sometimes what is required is that we want that the particular input stream should match at the beginning of a line or should match at the end of a line. So, like that. So, if we want that sort of modification, so this lex is more flexible. Like if, for example, if I write like something like this hat symbol and then I write if, in that case if this is my input file, then in some line if if is the first 2 characters of the line, then only it will find a match for this particular pattern. Whereas, if this if appears somewhere here, then it will not find a match with this particular pattern, because it is not starting with the beginning of the line. So, this way this pattern is more powerful compared to the regular expression that we are familiar with theoretically. So, that is why it is written as pattern, and with the pattern you can give the corresponding action. So, this translation rules, it will have all the patterns that the program should recognize as valid input patterns, okay, for the language, and then it will have the corresponding action. And while writing the action, so action is basically some C code. So, this is some again some C code, and these actions are made part of the file lex.yy.c. So, whenever some pattern is found, so the corresponding action is executed. So, this action may be just printing the token that it has found, or it may be returning the token to the parser. So, that way you can think about different actions, like if it is an identifier, you can think about installing the identifier into the symbol table. If it is a number, then you may think about installing it into the number table. So, like that we can think about different actions. So, those actions are taken care of by this action part. And while for writing these actions, so we may need some additional function. For example, like for installing a symbol into the identifier into the symbol table, we may have a special function which is a installation routine. So, that routine may be written as part of the auxiliary function, and from this action part you can just call this routine. So, that is how this lexicon this lex is going to be helpful. So, we will see some example by in which this lex has been used. So, so here in this part, so in this part of in this part of the so you see that the first the first percentage symbol, it appears at this point. So, before that whatever you have, so they are actually coming to the definition part. So, here you can have you can define all the constants. So, they are manifest definitions of manifest constants. So, they are actually the tokens that we have in the language. So, these are the tokens. So, all tokens that you have, so you have to put it in this within this percent open brace percent close brace symbol. So, this is again another standard that is introduced by this Lex and parser generator tool YAK. So, they use this within this symbol whatever you put, so they are taken as token, and what the system will do is that for each of these symbols that I have here, so it will put a number. Okay. And later on, so if you look into the action part, so when it is returned, then so it is actually the corresponding number that is assigned by this lexicon analysis tool. So, that will be returned. So, that is, so they, if you look into this lex.yy.c file, so you will find that there are hash defined lines that have been generated, hash defined LT1, hash defined LE2. So, like that it has generated all those hash defines for this part. Then comes the regular definition part. So, in the regular definition part, so we will be writing some definitions which will be used as pattern while we are going to the second part. So, here I have got the delimiters. So, delim is a regular definition. So, we have got this is the blank, there is a blank space, tab and new line character. So, to just to mean that this is a tab, not the character T. So, it is written as reverse slash and then T. So, reverse slash in Unix operating system, so it is taken as an escape character or escape sequence, and the slash T, it stands for the tab symbol. Similarly, slash N stands for the new line symbol. And as I said previously, so this is an aggregation of symbols. So, this blank, tab and new line, they will be called delimiter. So, the white space is another definition. So, this is within brace means that this is going to be replaced here. So, this delim definition of delim is going to be replaced here, and then there is a plus. So, any number of occurrence of those symbols. So, this is basically the white space that are occurring. Then for the letter we say then A to Z, capital A to Z and small a to Z, and these are the range that are there. So, these are the augmentations that are done for the basic with the basic regular definition. Okay. So, in basic definition, so this A to Z was not used, only for our understanding. So, it has been introduced and Lex has adopted that. So, Lex has adopted that A to Z as a range, small a to small z as a range. Similarly, digit is another definition for 0 to 9. Now, it defines the ID. Okay. So, ID it says it is a letter followed by letter or digit and then star. So, this is similar to regular definition. Then number, so digit plus, so one or more number of digits, then we have got this thing this dot, and so this dot has got some special meaning in case of Lex tool. That is why there is a escape sequence here, the escape character backslash and then this dot, and then we have got digit plus. So that after that I can have any number of digits. So, and this whole thing there is exclamation question mark, that means this whole part in this part is optional. So, you may or may not have the fractional part in a number. So, that is why it is like this, but at least one digit will be there, then there can be a dot and any number of digits, and after that there can be 10 to the power, the exponent part. So, for again this part is optional, okay, this whole part is optional. So, we have got e, then after e we can write the digits directly 10 power 25, 30 like that, or I can have plus minus, I can write like 10 power minus 30 or 10 power plus 25 like that. So, that is captured by this plus minus and this question mark. So, this question mark means the 1 or 0 or 1 character. So, that way, so we can have at most one occurrence of those symbols. So, this number is the regular definition for this part. So, it defines the both integer and floating point numbers. Okay. Then after that it comes to the third part of the regular expression, third part of the Lex tool, that is this portion. Okay. So, what we are doing here is that we are, so for white space, so there is no action and no return. So, if that yylex function is called and the yylex function finds that the yin pointer is at some white space, so it will simply advance the yin pointer. So, it will not return anything. Then if it finds the characters I and f, in that case, so it matches with this particular definition if, and in that case the action that is taken is return if. So, as I have told you that each of these definitions, so they are converted into some constants. So, that constant value will be returned. So, you have to interpret what is this constant. So, if you are just if you are calling it from the main program, and in the main program you are just printing the return value from yylex. So, you will find that it is nothing but a number. But if you once you know this thing, the values here, and these values are available in some header file, and if you include that header file in your program, and then you can just do a check and print the corresponding values. So, this if it finds that if it finds that characters I and f, then it will return the value which corresponds to this the capital IF symbol, that constant. If it finds this 4 characters T, H, E, N, then it will return the constant corresponding to then. If it finds ELSE, then it will find else. Then this ID is the ID, since it is within this brace. So, this entire thing will be replaced here. So, this ID will be replaced by whole thing. So, this is just there. So, that definition of identifier will come, and then the action part, you see there are two things. One part is it is returning the constant corresponding to ID, the token corresponding to ID, but before that it is setting another variable yyl to this return value of this function install ID. So, install ID is a routine, it is an auxiliary routine that this lexical analysis, this specification file will have. So, this install ID routine is written here. So, this is the code is not written, but essentially what it will do, it is this function is to install the lexeme whose first character is pointed to by text and whose length is length into the symbol table and return a pointer thereto. Now, there are a few special variables that we have come across, the text and length. Now, if this is your input stream, as I said that this in pointer is initially pointing to the first character, and then as you are calling this yylex function, this in pointer advances. Suppose at this point of time, this suppose at this point of time the in pointer is somewhere here, and then we have given a call to yylex, and here this is the next few characters that matches with some pattern. And after it has found the match, what is done, this text will point to this sequence of characters. So, this will be text will be pointing to this, and length variable will contain how many characters are there in this part. Okay. So, these information are available in the in these two variables. So, after you have returned from yylex function, if you just print the character string text, then you will find the string that has been matched with the token that is returned, and the length it will have the length of the string, like how many characters were there in that particular string that has matched. So, this way you can think about writing you can think about writing specification files. Similarly, you see that this number. So, this number when it matches with the number, then it is the action that is taken is return number. So, that is the token that is there, but it also calls a function yyLval equal to install number. So, this this yyLval. So, this is another important variable yyLval. So, it is you can read it as a value of the value attribute of the token, you can say it like this, it is the value attribute of the token returned. So, this the token returned is number, but what is the corresponding value. So, if you want to return it, so then this yyLval variable can be used. So, normally this parser, it has got access to all these variables like text, yleng, ylval and all that, and ylval is going to be a very important attribute that you can see later. So, here for the number we have given a call to this install number. So, the number is installed into the number table, you can say. So, this is the corresponding function install num. So, puts the numerical constant into a separate table. So, we assume that it is put onto a table, and the index of that table where it is put into. So, that index is returned into the return from this function, and that is assigned to yyLval. Similarly, for this install id function also, the wherever the place at which the particular lexeme was installed, okay, this in the symbol table, that index is returned, and this yyLval is made to contain that particular value. So, these index values will be available to the lexicon the parser tool or some high level program which is going to use this lexicon analyzer as part of it. So, in this way you can write down specification for different regular definitions. So, for the entire programming language, you see that the designing lexicon analyzer is so easy, because you do not have to do any of those NFA, DFA etcetera by hand. So, all that you need to do is to write down the corresponding regular expressions and think about the actions that should be taken if those if those patterns are found on the input stream. So, based on that, so you can design this lexicon analyzer, and rest of the thing is taken care of by the lex tool. So, it can automatically generate code for that portion of the tool. So, this is how this lexicon analysis tool works. So, to summarize our discussion, so in this chapter, so we have seen several things. First of all, words of a language can be specified using regular expressions. So, that is the first thing that we have seen. If we do not do that, if we cannot do that, then it becomes very clumsy, because there are so many different types of words that may be possible, and it becomes very difficult for the compiler designer to figure out what are the valid words and what are the invalid words. And so, this regular expression based formalism, it helps us to write down the to tell what are the valid words of the language. And once these regular expressions have been written, so we can design non-deterministic finite automata and deterministic finite automata that can act as acceptors. So, suppose corresponding to a regular definition, we can design a finite automata, and then the input stream, based on the input stream. So, it can scan through the input and going from one state to the other. When the input is exhausted, if it comes to a final state or an accepting state, then that particular word is valid, otherwise it is not valid. So, that way they can act as acceptors. And we have seen techniques by which regular expressions can be converted to NFA, and after that the NFA can be converted to DFA. So, this way this whole process there exists a very sound theoretical foundation for determining valid words of a language. And after that, as an add-on, so this with the from Unix operating system, so we have got the tool Lex that can be used to generate lexical analyzer for a language. And then you can also in other operating systems also these tools now have been ported. So, they are in other systems also they are available, and several augmentations have also been done, but it will require quite some time to discuss on them. So, I would suggest that you refer to some manual for this Lex tool to get a detailed understanding of how this tool can work. Okay. So, that way we can design this lexical analysis tool. So, with that we conclude this part. Of course, we will look into quite a few examples in the next classes.